Okay. Alright, so hari ni kita akan sambung kita punya kelas. Our lesson we stop the last time at introduction of QC and its roles. Kita dah tengok dah nama, you have been introduced to what is QC, what they do, and I've given you a tutorial dekat dalam Google Classroom. So today we are going to discuss that tutorial. And then kita akan sambung the lesson, which is the rest of chapter 1. So hopefully by the end of this class, kita boleh habiskan chapter 1. And then we are going to do some like quizzes exercise. Dia bukan like pop quiz, dia bukan macam test ke apa, dia hanyalah exercise. Tidak ada markah yang akan diambil. Okay, dia hanyalah latihan yang saya buat untuk tengok sama ada kamu berapa jauh kamu faham, how well do you understand the lesson. Okay, which also encourage some participation from you guys. Saya tak nak just one way communication, saya cakap and kamu just turn on the screen. Okay, so let's get to the lesson, which is mana tutorial. Okay. So this is one of your classmates, one of you punya submissions lah, 34, 100. Okay, so saya pinjam, kita akan guna this submission untuk discussion. Okay, so this is the tutorial for introduction to QC and its roles. So first question, quality control is a procedure and guidelines to ensure the manufactured products are up to standard. True or false? The answer is true. Okay, so QC, as I have as I have put it in the lecture note, the manufacturing flow it starts from a supplier and then it goes to the warehouse of the manufacturing chain. And then from the warehouse, I can distribute the raw materials, all the ingredients to the production. And then the production will formulate, will make all the product. And then production will pass it on to QC, where QC will perform various types of analytical quality control tests on the product before it can be released to the market, which will be reviewed by QA, quality assurance. Okay, QA is like the police of the whole thing. They can monitor everyone's work. They make sure everyone follow protocols, follow guidelines. Because if someone doesn't follow protocols, someone doesn't follow the guidelines, mistakes could happen, errors could happen. So the protocols and the guidelines are there to minimize and to regulate, so that it will be easy if some accidents happen, if some incident happen, kita boleh tengok balik, we can review back, where was the mistake, how can we prevent it in the future. Okay, so that is the QA punya role. Sekarang dalam this topic kita nak fokus on QC. So apakah tugas QC? So QC is like a whole system, dia buat pelbagai kerja. And basically one of the role adalah untuk make sure all the products are up to standard. Dia kena pastikan semua bahan-bahan yang dibuat di dalam manufacturing process tu mematuhi piawaian, mematuhi spesifikasi yang telah ditetapkan. Okay, so that is the role of QC. Question number 2, choose the correct components of QC. So these are 4 components yang diguna pakai dalam manufacturing industry. The first one is sampling, specification, testing, and documentation. So the question asks whether uh, does all of this apply to QC? And the answer is yes. Okay, so the question basically asks you to choose which one apply to QC. Apakah komponen-komponen kerja dalam QC? Dia bagi these 4 things for you to choose from. And the answer is all of them. Okay, sampling pun kerja QC. Some of the some of the raw materials will have to be sampled by QC department. Specification standard tu perlu ditetapkan oleh QC department. Macam mana nak buat test? How do we devise? How do we perform all these tests? Macam mana kita nak pilih which method is best to use? Which chemicals? Which instrument? So all of those need to be done by the QC department. Kalau dah cara untuk buat pun ditetapkan oleh QC, the work testing is also QC punya job. And lastly, after you have performed all the tests, kamu kena buat documentation. You have to write the reports and submit the report for safekeeping. Okay, so all of these are the components of QC. Next one, choose the correct reason why an analytical balance is best to be placed on a marble working bench. So this question is based on the video. Weighing balance, lesson number 2. Tak silap saya. Okay. So lesson number 2, introduction to instrumentation analysis, role of QC. So dekat dalam every lesson saya akan I've attached these videos. So and at every tutorial also saya tulis note description, dia cover lesson berapa sampai berapa. So dalam this one, if you notice, saya tulis dekat instruction, my bad. Dekat bahagian instruction, cover from lesson 1 to 4. So all the videos yang attached dalam lesson 1 to 4 will be covered dalam this tutorial yang saya buat. Did somebody do something? Saya dengar bunyi notification. Tapi tak nampak apa-apa pun. Okay, so kalau tak ada, saya go back to the question. Okay, so soalan ni, choose the correct reason why an analytical weighing balance is best to be placed on a marble working bench. The answer is to minimize vibration. Okay, so weighing balance, analytical weighing balance is very sensitive. Dia boleh terkesan from angin, terkesan from vibration, so slight movement ataupun hentakan. So kalau kita letakkan this weighing balance on a wooden table, plastic plywood table, semuanya mudah mudah bergegar. If you just like tap on it pun dah boleh rasa vibration. But if you use a marble working bench which is dense, tumpat, okay, so dia tidak mudah terkesan from movements and vibrations, dia tak akan affect the weighing balance. Okay, because kalau ada bergegar, maybe some of the things that kita timbang tu boleh like fell off the weighing balance, ataupun the reading, the spring within the weighing balance could be affected by the vibrations. That could affect the reading. So if the initial weighing sudah is compromised, sudah tak betul, so the following, semua kerja-kerja yang kita buat will be based on the timbangan kita yang pertama tu. So all the work yang kita buat semua tidak akan betul, tidak akan tepat. So that is why it is crucial that we make sure our weighing is accurate and precise. Itu pentingnya kita letakkan weighing balance di tempat yang stabil, okay, to minimize vibration. Next one, it is not recommended to use the weighing balance near a door, window or air vents because it could be affected by air current. Okay, bila kita letak weighing balance kat pintu, bila somebody buka pintu akan ada angin. Okay, so that angin boleh meniup any timbangan kita. Because kita nak timbang dalam lab, kita timbang our samples would be in powder form, granules. Dia kecil, mudah sangat ditiup angin. So kalau letak dekat tingkap, letak weighing balance dekat tingkap, air vents, aircon ke, kipas ke, pintu, semuanya adalah sumber angin. So boleh compromise our weighing. Next one, the following are the roles of QC except. Okay, so semua ni adalah tugas-tugas QC, quality control, kecuali last one, the last option, which is approved products for sale. Okay, that is the role for QA, quality assurance. The following questions will be about lab tools. It is your job to identify what are they. So the first one here is, it is a glass cylinder. It is long. At the end, there is a stopcock, and there's the bottom end. It is narrow with a tip. Okay, and along the rod there will be graduation. So usually it's from 0 to 25 milliliter ataupun 0 to 50 milliliter. So this is called a Buret. We use this in titration analysis, volumetric analysis. The next one, this is a conical flask. So a conical flask looks like a cone, only upside down. Okay, there's a narrow neck and a wide bottom, wide flat bottom, so that you can place it on a bench. Tak jatuh. So dekat bawah ni adalah nama-nama lain untuk conical flask. Bukan nama lain, bukan nama-nama lain, nama lain. Ada satu saja lagi nama lain, which is Erlenmeyer flask. Erlenmeyer is the name of the person that developed this glassware. Next one is choose the correct reason why item number 2 has a narrow neck. Dia tanya, kenapa dia punya tengkok ni, kenapa why the neck is narrow? Kenapa tak lebar sama besar je macam bottom dia? Kenapa tak guna beaker saja? Kenapa perlu gunakan conical flask? So the purpose of a conical flask adalah untuk kita mix solutions. So in the lab, we will mix different kinds of solutions. So kalau nak mix, we need to stir them. We need to agitate them so that they mix together, so that things will dissolve better. So if we use a beaker, we need to if we swirl the beaker, it will tend to spill, mudah untuk tertumpah. So therefore kita kecilkan dia punya tengkok ni, and we can just swirl with us holding the neck and with minimal risk of spilling. Okay, kita tak nak any of the solutions tertumpah. So that is the reason why it has a narrow neck, to avoid spilling when mixing solutions. Next is item number 3. This is a pipette bulb. You will see all of this being used dalam lab class nanti. Okay, so in our practical class, these are the things, these are the tools, lab tools, glassware yang kita gunakan untuk perform different types of analysis, but mostly apa yang saya senaraikan kat sini adalah the tools, the glassware that we use for titration. Okay, titration is a big part of our practical class. It uses different kinds of glassware, chemicals, so it is easy for us to use it as an example, as a framework to teach you about analysis. Okay, so that's why saya pilih this lab tools, instrument, glassware that revolves around titration analysis. So ini nama dia adalah bulb, pipette bulb. Okay, we use it with a pipette which looks like this. Dekat bawah ni. The next question. These are a series of different types of pipette. So volumetric pipette adalah tool, adalah alat yang kita gunakan dalam makmal untuk accurately measure volume. Kalau kita nak mengukur isi padu dalam makmal, kita gunakan pipette. Tak guna beaker, tak guna measuring cylinder. Okay, because pipette is what's the word? It is validated and standardized, and it is more accurate than a beaker, than a measuring cylinder would be. So kalau kita nak nak gunakan, we need 1 milliliter of sulfuric acid solution. So kita boleh guna measuring cylinder, but it would not be accurate and precise. So accuracy and precision is very important in analysis, which would be explained in our next topic later. That's why pipette is very important. Kita guna dia untuk mengukur any isi padu yang kita perlukan. That's why ada pelbagai size kat sini. So yang paling kecil kat sini adalah 1 ml. This is probably 2 or 5. Sorry, this is 2, this is 5, 10, this is 25, and this is 50. Okay, so volumetric pipette, we use it for measuring volume accurately in the lab. Next one is volumetric flask. Okay, so in analysis, we need to prepare certain types of solutions with accurately known concentration, kepekatan. So concentration is very important when we are performing analysis because kita nak tahu berapa banyak, how many chemicals, what's the amount of chemicals we are using for a certain analysis. So that's why concentration is important. We need to know the exact amount. So kita tak boleh prepare any standard solution dalam conical flask ke, dalam measuring cylinder ke, dalam beaker. So we have created this glassware which is called volumetric flask. So kalau kita nak prepare contohnya 1 molar, which is the amount, the unit for concentration. 1 molar sodium hydroxide, kita akan gunakan volumetric flask. So in this case, volumetric flask ini datang dalam pelbagai size. So, dia ada dalam 10 ml, 25, 50, 100, 200, 250. So kalau kita nak prepare a certain volume, kita kena pilih the right volumetric flask. So in this case, dalam gambar ni, this is 250 ml volumetric flask. So dia tidak ada senggatan, as you can see, it is a clear glassware except for the bottom dia ada tulis lah dia punya, siapa dia punya pengeluar, what is the volume it can hold, kat sini 250, and then kat sini dia tulis all the specification lah, it complies to what standard, dia patuhi piawaian siapa. So macam mana nak tahu kita dah, kalau contohnya kamu masuk dalam makmal, kamu nak prepare 250 ml solution, how do we know kita nak stop kerana isi sampai atas ni ke, isi sampai kat certain level ke. So there is a line, a very thin line somewhere on the neck here. So kalau kamu nak prepare 250 ml solution, you just top up sampai that thin line. Okay, make sure the meniscus is dead on the line. Okay, dia tidak ada senggatan macam measuring cylinder. There just ada one thin line. That is the only graduation that is on a volumetric flask, and that graduation marks only 200 ml. Kalau dia tulis 250 lah. Kalau volumetric flask tu 100 ml, the line marks 100 ml volume. Okay, so that is the purpose of a volumetric flask. Next one. Blank personnel will accept and inspect any incoming materials at a manufacturing plant. So this is in the first lecture. A warehouse is the folks that is responsible for inspecting and receiving all the materials that comes to the plant. Okay, so kalau ada lori, kontainer besar-besar yang kamu nampak kat highway itu, when they arrive at a manufacturing plant, they will go directly straight to the warehouse, and then they will be greeted by the warehouse personnel, and then the warehouse personnel will go on check the stuff that they ordered. The barang-barang yang sampai itu akan datang bersama dengan satu sijil, kita panggil certificate of analysis. So dalam sijil ni, certificate of analysis adalah tersenarai all the details. Dia punya description, appearance patutnya macam mana, the content dia, ada berapa kilogram, ada berapa gram, berapa peratus keturunan purity, everything is listed in the certificate of analysis. Okay, so kita perlu check and compare betul ataupun tidak. Kalau tak betul, we have the right to reject, kita minta maaf. Okay, because kalau raw material sudah compromise, sudah macam tak bagus, that could affect our product yang kita nak buat dekat Kinau. Okay, so that is the job of a warehouse personnel. Next, sampling procedure will be performed by warehouse personnel for distribution and dispensing to production and QC department. The answer is true. Okay, so sampling procedure akan dibuat oleh warehouse personnel, but the procedure, the SOP, is developed by QC department. Okay, so QC department akan tulis lah macam mana nak perform sampling. Alat apa nak pakai, kena pakai what's the gowning procedure, kena pakai PPE apa, what's the step by step procedure. Semua tu SOP akan dibuat oleh QC, and QC will pass the SOP to warehouse, and the warehouse personnel will have to perform all the SOP steps kalau nak buat sampling. Okay. Next one, choose the correct reason why a personnel must wear proper personal protective equipment while performing sampling procedure. So this should be easy to understand now, because we all have been wearing masks. We all have been wearing masks for the past like almost 2 years. Okay, the reason why we wear masks adalah to avoid cross contamination. The same reason why we do it in the lab. Okay. Sebab tak nak ada cross contamination. Kalau dekat luar sekarang kita pakai mask to protect ourselves and also to protect other people, because we could be carrying the virus also. So kita bukan saja nak lindungi diri kita nak lindungi orang lain juga. So the same concept applies dalam mask. Kita bila dalam production, kita nak buat barang yang berkualiti, selamat dan berkesan. So our raw material mestilah bersih. So kalau kita tak bersih, and then kita tak pakai any PPE, tak pakai mask, tak pakai any the jumpsuit, the hairnet, the hair cover, the gloves, we could be transferring contaminants ataupun like other stuff, microorganism, kita tak tahu, tak nampak, into the product, and that thing could be in our product, into the public. So that is a risk that we don't want. So that's why kita pakai PPE. The same also kenapa kita pakai, because these raw materials could be hazardous to our health. Dia punya fumes, dust, habuk, kalau kita breathe in could affect our lungs. It could affect our health. So kita tak mahu kesihatan terjejas from inhaling all this. So that's why kita pakai mask. Okay? So itu maksudnya cross contamination. Contaminants could come from us, it could also come from the product, the raw materials. Next one, which is the last one. Next question. Choose the correct name for a reference book that contains a specific formulation, description, testing procedures for wide varieties of drugs. So the answer is pharmacopoeia. Okay, so this is also attached in a video in lesson 3. So what is pharmacopoeia? Okay, so lesson number 3, introduction to instrumentation analysis specific for quality control. So last week saya ada tunjuk satu document, okay, which is called standard testing procedure. It looks like saya tak share window. Oh. So I want to share my entire screen. So last week I've shown you a document that we use to perform analysis bila kita nak buat test kat dalam makmal. Okay, so you should be able to see on your screen now. So this is what we call a standard test procedure. So kalau saya dulu saya masuk dalam lab, saya nak test, saya nak perform test on a drug, saya akan cari file for the specific drug. So for example, this is a file, an STP for chlorpheniramine tablet 4 milligrams. So kalau saya masuk makmal one day and I found out, okay, that's my job today, saya kena test chlorpheniramine tablet. So I go in the office, saya cari file, the STP, which is standard test procedure for chlorpheniramine. So this is what I will see. Inside this document, it is listed all the tests that is required for the drug to pass. So kalau kita nak pasarkan ubat ni, tablet ni, batch ni, dia perlu pass all of this test. Okay, ada 9 test kesemuanya. If you scroll down, panjang lah, ada berapa page kat sini. So ada pelbagai jenis test, dia test dari pelbagai aspek. Ada 9 test kesemuanya. Okay, so how do we tadi nak nak kaitkan dengan soalan tadi, pharmacopoeia, kita create this STP based on pharmacopoeia. So what is pharmacopoeia? Dalam pharmacopoeia tu ada disenaraikan ke semua butiran tentang mana-mana ubat yang didaftarkan dalam sesuatu tempat, sesuatu negara. So basically, the four major pharmacopoeias that are available, that is widely used right now adalah US Pharmacopoeia, USP, British Pharmacopoeia, BP, European Pharmacopoeia, EP, and Japanese Pharmacopoeia. Selalunya negara-negara yang besar yang mempunyai pelbagai ubat, banyak sangat ubat yang didaftarkan dalam satu negara, dia boleh keluarkan pharmacopoeia. Kalau macam Malaysia, we are a small country, kita tak ada banyak, we don't have enough glossary. Kita tak cukup ubat yang didaftarkan. Ada requirement dia lah kalau nak buat pharmacopoeia ni. Okay, so kita tak ada pharmacopoeia. Tapi US ada, British ada, European nations ada, Japanese ada. So they have pharmacopoeia ni is like basically, saya selalu panggil it's like a kitab. Okay, because dalam tu semuanya disenaraikan. Macam mana nak formulate, macam mana nak buat sesuatu ubat tu. Dan kalau dah formulate, macam mana kita nak test sesuatu ubat tu. Macam mana, what is the description. Okay, rupa dia sepatutnya macam mana. What is the physical properties, pharmacokinetics, pharmacology of the drug, semuanya disenaraikan. Okay, lengkap. That's why I call it a kitab. Okay, kalau kita nak buat analysis, kalau kita nak buat any drug, kalau kita nak devise a new drug, we always refer to pharmacopoeia. Okay, because kita boleh refer lah dulu orang buat macam mana. How can we improve on this drug? Okay, that's why ada pelbagai jenis variations of drug. Ada ubat yang macam extended release. Kalau macam dulu dia makan just one dose, all the dose will be dissolved immediately. And then kita find out that this drug will work better if the dose is released extendedly. Dia akan diserap dalam badan secara perlahan-lahan. So for the first hour only 25% dissolve dalam badan. And then for the next 4 hours another 25%. And then another 25, sampailah 12 hours cukup 100%. So just makan ubat tu sekali saja, one day, and then you're good for the whole day. Tak payah makan 3 kali satu hari, 4 kali satu hari. So that is why we can make improvements, because kita ada all these details reference dalam pharmacopoeia. Okay, so that's why kita ada this standard test procedure. So kalau dalam makmal, disebabkan ada banyak sangat pharmacopoeia, dan dalam satu pharmacopoeia pun ada pelbagai kaedah untuk test satu ubat. So for example, chlorpheniramine maleate ni, kalau nak buat assay test, so ada pelbagai jenis, ada banyak kaedah untuk buat assay test ni dalam US Pharmacopoeia, USP. So which ones to choose? So the the QC personnel yang bertanggungjawab akan pilihlah which one is the best for us. Kalau macam kat Pharmaniaga, okay, kita ada instrumen ni, so tak boleh nak guna method number 1. Kita boleh buat method number 2. So we choose method number 2. Okay, so katakanlah USP punya kaedah tak padan dengan Pharmaniaga. Kita semua barang-barang kita tak ada seperti yang diperlukan dalam USP. So kita check BP pula. Okay, BP ada kaedah lain yang sesuai dengan kita. Kita ada chemical yang dia suruh guna, kita ada instrumen yang dia suruh guna. So kita guna kaedah yang ada dalam BP. Okay, so that is why ada pelbagai jenis pharmacopoeia, because there are different methods according to different requirements. So kita pilih just one specific method yang sesuai dengan kita punya benda yang kita ada, instrumen yang kita ada, chemicals yang kita ada, budget yang kita ada. Okay, so that's how we have a standard test procedure, this STP. And this STP is made by referring to those pharmacopoeia. Okay, so that's basically the first tutorial. Okay, so let's take 5 saat. Kita akan sambung with next lesson. Tapi dalam next lesson saya nak never mind. That's, kita akan buat that exercise at the end. Okay, so let's take 5. 9:55 kita sambung. Okay guys, I'm back. Saya tunggu screen saya buka. Alright. So, kita nak masuk topik baru, which is errors, accuracy, and precision. Okay. So before we get into all the details, I will have. I think it's better for me to give you a background so that you will understand why do you need to learn about errors. Kenapa kamu perlu tahu tentang ralat, the types of errors. Kenapa kamu perlu tahu tentang accuracy and precision. So for you to understand that, you need to know what exactly that the QC does. Okay, bila masuk dalam amal tu QC personnel, staff ni buat apa? Macam mana kita perform all these tests? Okay, so basically quality control is a lot of things. It is a whole system. Dia buat pelbagai kerja. As you have kita dah bincang tadi, dia ada pelbagai role, ada pelbagai peranan. And one of them, satu konsep yang kita buat kerja based on satu konsep QC ni. Okay, so this konsep ni adalah kaedah untuk mengawal ralat, method to control errors in analysis. So bila kita buat analysis, errors could happen. Ada risiko untuk kesalahan, kesilapan itu berlaku. So the errors could come from the person that is performing the analysis ataupun from the instrument, the lab instrument. Okay, so untuk mengurangkan risiko, to minimize the errors, we develop a method that would make us easier to control them. So kalau contohnya kalau somebody buat salah, kita boleh macam identify salah tu dekat step mana, because there are a lot of series in performing an analysis. Okay, ada pelbagai langkah, step by step, ada banyak procedure before we can finish, before we can complete certain tasks. So kalau in the end result yang kita dapat tu something is wrong. Okay, we analyze the result, cakap okay, produk ni tak pass this test. So kita tengok baliklah kenapa dia tak pass. Dia tak pass sebab produk tu sendiri tak bagus ke, ataupun kita buat salah, ataupun instrumen tak betul, perlu calibration, perlu service. So we need to investigate. So that is why it is important that we understand the types of errors, because if we understood the types of errors, we can determine, we can pinpoint, okay, if we perform, kalau this is the error, that means kita tak accurate. Kalau kita determine, oh, this is the error, that means we are not precise, the instrument is not precise. Okay, so that is why we are learning about types of errors and what is accuracy and what is precision. Alright, so for example, saya nak bagi satu contoh one type of analysis. So kat sini saya ambil the same document, chlorpheniramine tablet tadi yang Famanaga gunakan. Ini adalah test, assay test. Assay test adalah sejenis test yang kita buat untuk determine the content. Kita nak tahu dose dia berapa. So ubat ni, we claim it to be 4 mg per tablet. So kalau kamu tak perasan, semua ubat yang dijual dia ada ditulis dia punya dos berapa. Panadol 500 mg, Panadol Activas 650 mg. So doses are very important. So that's why we need to verify betul tak betul ini 4 mg, betul tak betul ini 500 mg. Okay, before we can market that. Kalau macam terlebih, it could be overdose. So bila patients makan, sepatutnya makan 2 dos, it could be safe, tapi disebabkan tablet tu overdose, patients boleh, it could get adverse reactions. Okay, kalau macam dia underdose, sepatutnya 4 mg tapi dia hanya ada 1 gram saja. So bila patients makan, there's no tak berkesan. Okay, so that is the reason why we perform assay test. So assay test, we determine the active ingredient, the API, active pharmaceutical ingredient of any drug. So ada pelbagai kaedah, and dalam this document for chlorpheniramine tablet 4 mg ni, kita gunakan kaedah HPLC. Kita gunakan HPLC is an instrument yang ada dalam makmal, dia separate the active ingredient from all the other ingredients, and the instrument boleh quantify, dia boleh kira, dia boleh measure berapa banyak miligram, what is the percentage of the API yang ada dalam tablet. So dalam ini disenaraikan dia punya release limit. It is called a release limit because sebelum kita boleh release it to the market, dia perlu pass the specification. So kalau ubat ni nak pass test ni, the end result should be 95 to 105% of 4 mg per tablet. Okay, ini maksud this is the the result yang kita patut dapat. So apakah maksud 95 to 105% ni? So this is the tolerance. Okay, because of the measurement of uncertainties, okay, sometimes ada sedikit ketidakpastian dalam bila manusia buat ukur, buat measurement. Sorry, saya direct translate dalam kepala. So machine also could have uncertainties in measurement. So kita bagi sedikit inilah ruang for that uncertainties, ketidakpastian dalam mengukur tu, dalam timbangan. Bila kita nak timbang certain value, that could be uncertainties. Bila kita nak dissolve 550 ml, there could be uncertainties. Okay, maybe glassware tu tak setepat yang setepat mungkin. So ada room for untuk kelonggaran yang kita bagi for all these uncertainties. So that's why ada macam dia bagi dalam range macam ni. Dia tak bagi 100%, tapi dia bagi range 95 to 105%. So what does this release limit means? So kalau kita buat test ni, kita dapati where's the whiteboard yang saya buat tadi? Kita dapati the result yang kita dapat adalah sepatutnya 4 mg kan. So katakanlah bila saya buat test tu, saya dapati the amount yang saya dapat adalah 3.2 mg sahaja. Okay, so the dose, the API yang ada dalam chlorpheniramine yang saya baru prepare, the first sample is 3.2 mg sahaja. Okay, the API, the chlorpheniramine API yang ada dalam satu biji tablet. So macam mana nak tahu ini menepati standard ataupun tidak? I would just have to bagi dengan 4 mg darab dengan 100. Saya akan dapat percentage. Okay, so 3.2 divided, kenapalah saya tak ambil number yang senang nak bagi. Boleh calculate dalam kepala. 3.2 bagi dengan 4. So the answer is 80% kat sini. Yep. So 80% darab dengan 100. So 80% is below the release limit. Okay, 80% is below the release limit. The lowest value at the limit adalah 95%. So kalau saya dapat below this value, tak pas lah, the product yang saya test tadi tu fail the test. Kalau saya dapat within 95 to 100, it passes the test. So kat sini dah convert. The lowest amount in milligram adalah 3.8, the highest amount is 4.2 milligram. Okay, so ada sebabnya kenapa kita bagi dalam bentuk range macam ni. It is because of uncertainties of measurement. Kita nak measure, manusia nak mengukur, boleh jadi tak betul. The instrument also could produce some uncertainty. So that's why kita bagi dalam bentuk range. Alright. So the rest adalah dia punya kaedah lah, method apa kita nak guna, HPLC, and these are all the technical parts. Macam mana, apakah alat yang diperlukan. So you don't need to worry about this yet. Okay, saya just nak kamu faham how, in essence, in a nutshell, what is the main concept, how do we perform a test, how do we perform an analysis. So basically, we need to prepare two solutions. Okay, dua larutan yang kita perlu sediakan. Kita perlu sediakan standard solution dan juga sample solutions. These are the two types of solutions yang kita perlu prepare. So standard solution ni adalah bahan yang mengandungi active ingredient sesuatu ubat itu sahaja. So for example, kalau kita nak test chlorpheniramine tablet, kat sini ada dia tulis kat sini Kalau nak prepare standard solution, you weigh accurately 100 milligram of chlorpheniramine malate working standard. Okay, so working standard is a substance that contains only chlorpheniramine malate. Okay, so it is high in purity, ketulinan yang tinggi, dia tidak mengandungi bahan-bahan yang lain. Because ubat kita tu, chlorpheniramine tablet, dia bukan sahaja ada API, bukan sahaja ada chlorpheniramine malate, tapi dia bercampur lagi dengan bahan yang lain macam bonding agent, coloring agent, coating agent, other excipients lagi. So dia punya ketulinan rendah. So ada sebabnya lah kenapa dia perlu bercampur, because kita nak hasilkan dalam bentuk tablet, nak bagi dia keras, okay, nak bagi dia mudah bertindak balas dengan the mechanisms in the body, the pharmacokinetics, the pharmacology. So it is easier for people to consume kalau dia disalut, ada coating. Kalau tak, maybe pahit, orang tak lalu nak makan, muntah. So that's the reason why kita mix with other excipients. Okay? That's why kalau kita nak tentukan, if you want to determine the amount of the API in a tablet, kita perlu bandingkan dia dengan a substance that is higher in purity. So kalau dalam chlorpheniramine tablet, the API is chlorpheniramine malate. Ada chlorpheniramine malate dalam tablet tu. So kita kena bandingkan dia dengan something that is higher in quality. Okay, yang kita tahu it is 100% chlorpheniramine malate. So this is the thing yang kita panggil sebagai a reference standard. So all the pharmacopoeias, USP, BP, JP, EP, dia jual all this reference standard kita panggil. So dalam next chapter kita akan discuss dengan lebih lanjut what is a reference standard. For now you need to understand whenever we want to do an analysis, bila kita nak buat test, kita perlu bandingkan our sample, our product with a standard solution. Okay, so analogy that I always use adalah when we as humans, when we want to make something good, kalau kita nak buat nak masak something, we always refer to a recipe. Ya, orang kata okay, kalau guna recipe this person, okay, confirm sedap. Nak masak ayam rendang, okay, guna recipe from this person, confirm sedap, ramai orang suka. So that is the standard that we use. So the same concept basically applies kalau kita buat analysis dalam makmal. So we want to make sure that the product contains a certain amount. So we compare it to the best, which is the reference standard. Okay, so that's why we need to prepare a standard solution. So kalau kat sini dia suruh timbang 100 mg, just a small amount, 100 mg chlorpheniramine malate dissolved dalam 50 ml volumetric flask. So we have prepared a certain concentration of a standard solution. So dalam 50 ml solvent ada 100 mg chlorpheniramine malate. So that is our standard solution. And standard solution ni selalu kita prepare in duplicate, kita prepare dua. So ada dua volumetric flask lah. Okay, so that's why kat sini saya tulis in this whiteboard, we need to prepare two solutions, standard solution and sample solutions. Untuk standard solution kita prepare one duplicate. So ada dua volumetric flask of the same thing. Ada sebab dia kenapa, which I will elaborate later. And solution number two adalah sample solutions. This one adalah our tablet lah, kita akan grind the tablets and then kita akan dissolve dalam solvent and kita akan prepare sebanyak 5 duplicates. So in total we have 6 volumetric flasks of sample solutions. So if we take a look at the document here, kita buka dekat bahagian assay preparation, which is sample preparation lah, kita nak determine the tablets. So dia suruh ambil 20 biji tablet, chlorpheniramine tablet, finely ground. Okay, kita perlu tumbuk dia sampai jadi powder, jadi serbuk. Guna pestle and mortar, grind the tablets and then timbang 90 mg. So kalau kita nak prepare 5 duplicates, 6 volumetric flask of sample, kita kena timbang 90 mg ni sebanyak 6 kali. So we prepare 6 volumetric flask. Kat sini dia suruh guna 25 ml. Kecil sajalah. So 25 ml volumetric flask, we prepare 6 of them, timbang. The first one masuk 90 mg. The second, the second one also masuk 90. The third one masuk 90 sampailah 6. Okay, and then follow the same procedure. Add 15 ml of diluent and then top up and then everything sampai habis. Okay, so now in total we have 8 volumetric flask. Okay, 2 daripadanya adalah standard solution dan 6 adalah sample solution. So my point here is, saya nak kamu faham, bila buat test, we always compare our sample to a standard solution. Kita nak bandingkan kita punya produk tu dengan sesuatu yang tinggi kualiti dia, tinggi ketulinannya. That is the first thing yang saya nak kamu faham. Okay. Number 2 is kita prepare duplicate ni. Kenapa kena prepare 2 solution for standard solution? Kenapa kena prepare 6 for standard solution? So the reason is, saya nak bring back to the lecture note. Mana dia? Dalam lecture note ni saya kata QC is basically a method to control error in analysis. Kita nak mengawal ralat yang mungkin boleh berlaku bila kita buat test. Okay, so mana dia? Okay, so bila kita buat test, bila kita buat timbangan, macam kamu nampak dalam this document tadi, kita kena timbang. Okay, untuk standard kita kena timbang 100 mg sebanyak 2 kali. Okay, we need to weigh 100 mg, very small amount, 100 mg, sangat kecil. Kita timbang 2 kali. Untuk sampel kita kena timbang 90 mg, okay, which is even smaller, sebanyak 6 kali. So the reason why we perform duplicates, kita buat banyak kali adalah untuk test, untuk so that we have a series of results in the end. Okay, katakanlah in the end kita akan dapat bacaan. Our target is 95 to 105%. Itu target, ini target kita. Katakanlah bacaan nombor sample result. Okay. Katakanlah sample result number 1 dapat 100%. Sorry. 100%. Very good. Okay, number 2. Number 2 katakanlah dapat 102%. Oops, sorry. Lupa sama dengan 102%. Which is still good within the release limit. And then number 3 katakanlah dapat 90%. So something wrong has happened. And then flask number 4, 88%. Something has gone wrong also. And then flask number 5, 70%, which is even worse. And then number 6, okay balik, 97% katakanlah. Okay, so this is the reason why kita prepare duplicate. Kita nak tengok kenapa tak konsisten. Kalau kita timbang everything 90 mg, okay, 90 mg dissolve dalam 15 ml, everything is the same. Kenapa end result berlainan? So maybe error, maybe kita timbang, kita record 90 mg tapi bila kita buat timbangan tu tangan kita shaky, tertumpah before kita dissolve dalam volumetric flask. So instead of 90, maybe only 70 mg saja yang kita masukkan dalam volumetric flask. Okay, so that's why kita buat kita prepare solutions in duplicate, because kita nak tengok trend. Kita nak compare, kita ni accurate ke tidak, precise ke tidak. Kalau kita precise, we would get like the same readings again and again. Okay, a reading that is precise is kalau kita buat 6 flask, all of them would be like close with each other. Kalau the first one is 100, the second one is like 100 juga. The third one would be like kalau tak 100 pun maybe close to it, like 98%. Okay, so kalau kena 6 ni lebih kurang sama, that is precise. So seorang itu sangat jitu, dia boleh dia punya ukuran, dia punya measurement is consistent in all of the preparations. Okay, kalau orang tu consistent and then there's nothing wrong with the result, the instrument is consistent also. Okay, so kita boleh investigate lah. Kalau macam betul saya dah timbang 90 mg tapi bacaan still tak betul. So maybe the instrument pula tak betul, maybe the weighing balance dah tak betul, maybe the spring needs to be serviced, kena tukar spring baru. Maybe something is wrong with the weighing balance. Kalau bukan weighing balance, maybe the HPLC, okay, yang tak betul, maybe kita kena calibrate balik. So that is the reason why kita prepare multiple flask, multiple duplicates. Kita nak tengok trend. So kalau trend ni consistent, maksudnya everything is working fine. Orang yang buat kerja tu buat kerja dengan betul. Mesin yang sepatutnya berfungsi dengan betul. Okay, so kalau kita prepare just one solution saja, you have to understand this test kita bukan buat just one time. it is kita buat chlorpheniramine tablet ni just not one day. Kita buat every day, every week, multiple batches in satu bulan. So kalau lah macam that one day orang tu buat okay 100%, dia buat kerja betul, dia prepare one solution only. Tapi kalau esok lusa dia buat benda sama juga, maybe timbangan dia tak betul. Maybe dia prepare only 90%, tapi dia tak boleh bandingkan dengan sampel yang lain sebab dia hanya prepare satu solution. So dia tak tahu, kita tak tahu whether dia buat kerja tu, dia buat timbangan tu betul ataupun tidak. Instrumen tu berfungsi dengan betul ataupun tidak. So we need something to compare our work with, which is duplicates lah. Okay, kita nak tengok trend. Kalau ada trend, kita boleh check in the moment. Kita boleh investigate. Kita boleh pinpoint where is the error. Kat mana kesilapan. Okay. So that is why kita prepare multiple duplicates. That's why saya kata QC is a method to control analysis. Alright. So let's take 5 slides. Saya punya tekak dah kering dah. After this kita akan go take a look at the types of errors. Okay, so kalau kamu buka dalam lecture note ada 3 lah. So let's take 5 slides. Kita akan sambung in 10:25. Where's the Google Meet? Okay guys, I think this sampai sini saja kelas hari ini. Because saya tak free. Saya akan bagi macam saya cakap tadi, kita dah basically saya dah cover about accuracy and precision. So saya akan bagi another like bukan tutorial lah. This one tak akan kira masuk grade tapi just an exercise we do as a homework that covers about QC, errors, types of errors, accuracy and precision. Okay, so kita akan discuss that dalam next class. And then kita akan sambung masuk dalam chapter 2. Okay, so any questions tentang today's class? Hopefully tak ada.
No sir.
Okay, thank you. So I'll post the exercise dalam for the homework dalam Google Classroom. So you do it. Next week kita discuss. Okay. So thank you all. See you next class.
Okay sir, thank you.
Okay, bye bye.